Hello, Precalculus student. This video is for Chapter 3.2, Quadratic Function Part 2. We're going to continue to look at features of a quadratic function relating a formula with the features of a quadratic graph. When we look at a quadratic graph, we say that it would have some zeros. It might have might have no x-intercept or 1 or 2 x-intercept, but it would have 1 y-intercept. So if someone gives you a formula, so how can you find those intercepts, x and y intercepts? And how do I know when it has 0 or 1 or 2? Okay, so to find x-intercept is when the graph, like, so if I have an x-intercept, right? So it'd be like here, right? This 2 point that's sitting on the x-axis that the parabola cut intercept it with. So you can see that y is 0. So basically to find the x-intercept, you solve f of x equal to 0 because all these points would have y equal to 0. When you solve it, because it's a quadratic function, right? You have a complex number as answer, then you have no, I should say, there's no x-intercept because you can graph a complex number on this x number line, right? And if you only have one solution, that means you will have one intersection, and if you have two, then it would be something like that, or opposite, facing down. To find y-intercept, how the graph cut the y-axis, you just plug in. So what the y-intercept is when x is equal to 0. So you just plug in x equal to 0, and that would be the y value on the y-axis. So let's try two examples. First is find x and y-intercept of x squared plus 3x minus 4. So x-intercept, remember x-intercept is to solve the equation when y is 0. So we just say x squared plus 3x minus 4. This is f of x. And we just solve when it is equal to 0. So we use factoring to solve because it's quadratic. So negative 4 and 3. Two numbers, when they multiply, they're negative 4. When they add, they have 3. It would be 1, 4, but negative 1, right? And because it's just x squared, so I can just factor it right away. X minus 1, x plus 4. You can see that when you multiply them, they're this. And then we split it into 2. X is equal to 1 and x is equal to negative 4 are the zeros. So that you can imagine that you have a graph. The A is 1, right? A is 1 is positive, so it's facing up. And then you would have it would cut the intercept here, and it would cut a negative 4 and facing up like that. Right? So that's the two x-intercept. So x-intercept is 1, 0 and negative 4, 0. What about y-intercept? So this is x-intercept. Y-intercept is, just plug in 0 in the original formula. It's f of 0. F of 0 means 0 plus 0 minus 4. So that's 0, 4. 0, negative 4. So equal to negative 4. So you know that on the y-axis, it's there's like that. So you can graph the function like this. Yeah. Why do I this is not the vertex. The vertex is actually halfway between the two x-intercept. You can use the two x-intercept to graph, although you would not know how low the vertex goes, so you have to plug it in. Find the x-y-intercept of 2x squared minus 4x plus 5. So x-intercept first, which is just solving a quadratic equation of 2x squared minus 4x plus 5 equal to 0. In chapter 3.1, we talk about solving these. How do I solve? X is equal to a, b, c, right? X equal to negative b, so negative of negative 4 become 4, plus and minus b squared, so negative 4 squared, minus 4, a is 2, 4ac, all over 2a, 2a is 4. We know this is facing up, so let's see where the x-intercept is. So if it is just it could just be a irrational number, but let's say, but inside is 16 minus what? 40. That is negative 24 square roots, which is a complex number. Do you notice? Anytime you have, if you want to, you can write square root of 24i and stuff. But there's no need because we're just solving for x-intercept. So you say complex solution. That means there's no x-intercept. No x-intercept. We know that This is something, this is a parabola that face up because A is positive, but it doesn't cut the x-axis. So it would be something like, you know, here, like that. So it's does not touch it. And we can find the y-intercept. Y-intercept is easier. It's just f of 0. F of 0 is 0 minus 0 plus 5. So you can see that it's 5. So the x-intercept, the y-intercept is 0, comma 5. So there is a point here. So it is harder to graph it. So you really need a vertex to find out, to exactly graph it. So the x and y-intercepts are defined that way. And you can use this method to calculate if there is x-intercept or not. That's not necessary have one. So after we know all this connection between a formula and a graph, we're ready to actually, if someone gives you a formula of a function, to graph it. What is the point of graphing it? Because if you graph it, you can find the domain and range of this function. And you can also tell if there is a maximum or minimum point. So the first one is f of x equal to negative 3, x minus 2 squared minus 3. Did you recognize that this is a vertex form because I have a group of x squared term and then a number outside. So write it as write the template, x minus h squared plus k. You can recognize that a is less than 0, face down, right, set face, and then h is 2, k is negative 3. So the vertex is 2 comma negative 3. So once you know the vertex, you know a lot of stuff. So the process of graphing is sketch the of course you have to solve negative b over 2a, and then you sketch the vertex, right? So we find the vertex. So now the first thing you do is 2 negative 3, 1 2 negative 3. Sketch this point, sketch the axis of symmetry, which is x equal to 2, right? AOS is x equal to 2. And then you need to find another point because I need to know, well, we know it is facing down, so I need another point, right? But where is it? Is it this way? Is it this way? Is it really skinny? So the one we can do is find either another point or the y-intercept, because y-intercept is really easy to find, which is f of 0. Now, f of 0 is not the negative 3. You have to actually do negative 3 times 0 minus 2 squared minus 3 because it's a vertex form. So it will be negative 3 times 4 minus 3. Negative 12 minus 3 is negative 15. So there is a y-intercept of 0, comma negative 15 here, right? 2 away from the axis of symmetry. So you would reflect, because this is axis of symmetry, reflect 2 more. You will have another point, also negative 15, and then you can sketch it. So you get the vertex, you get 1 point on the y-intercept, and then you reflect. Okay, so this is 2 away. How do I know it's 2 away? Because the vertex is 2 comma negative 3. The x away from it is that. Okay, so if you do 2 away from it, that means 4 something, 4 negative 15 is another point, and you can just sketch it like that. You would know how wide it goes. You can see that there is no x-intercept, so if you solve it, there's nothing. Okay, you would solve a complex number. So the second one, graph this. Okay, when you graph this, do not use table, because you already know a lot of features about the quadratic function. We don't use table, we use characteristics. Okay, so and a table is not reliable also, because you can see just a part of the function. So what did we do? Vertex first. Now we cannot read off like HK here. This is not 4, 3, because it's not a group of terms. So I know A is 1, right? A equal to 1 positive. We know that it is facing up. And then the vertex is what? You have to do h first, 1 by 1, negative b over 2a. That is negative 4 over 2, so it's negative 2. And then k is f of h, so it will be f of negative 2. So it will be negative 2 squared plus 4 times negative 2. Oh, this is a square. Plus 3. So that means 4 minus 8 plus 3. That is 7 minus 6 is negative 1. So the vertex is h is negative 2, and then y is -1. Is it -1? Yeah, -2, -1. I just want to double check that it's right. So, and it's facing up, so I would kind of sketch it here. -2, 1, 2, and -1. So, but how wide do I go? So I have to do the y-intercept. Just get another point. The easiest way is because the y-axis is very close to the parabola, you say the y-intercept is f of 0. Okay. There's no need to solve those x-intercept because just you have the vertex already, which is very good. You do the axis of symmetry. X is equal to -2 AOS. And then you would just get one more point and reflect them on both sides. What is f of 0? F of 0 would be equal to 0 plus 0 plus 3 is actually equal to 3. So you would have a point of 0, comma 3. 0, comma 3. So this is 2 away from the axis of symmetry. So 2 away from it, I will also have a 3. And I'll graph it. So that's how I graph it. So if you solve it, that should be a 2 X intercept also, but we don't need to. So that's how you graph a quadratic function by, just knowing the important features, the axis of symmetry and the vertex. The next thing is the reverse. If someone gives you a graph or some information from the graph, like what points it has, what's the vertex, can you write the equation out, like relating the equation with the graph? So the way you do it is you find the HK, find the vertex, and then so because your template is always y equal to a x minus h squared plus k. So if you know the vertex, you almost know the whole thing except for a. So how can you find a? You find one more point and you plug into x and y to solve for a. For example, someone tells you, oh, I have a quadratic function. The vertex is 1, -4, pass through 2, 3, but I lost the formula. Can you find the formula? So what you can do is, because it's used pass through the vertex, so I would write the template. Y equal to a x minus h. H is 1 square plus -4. So that's mean -4. So this is the actual formula. But I don't know K, I don't know A, so what do? I use this XY to plug it in. So 3 would equal to A, 2 minus 1 square minus 4. So 3 equal to A times 1 square minus 4. So 3 equal to 1A minus 4. So what is A? A is 7. So the formula is, the function is f of x equal to 7 x minus 1 square minus 4. So once you have the vertex, you would actually almost have the whole thing except for a, and then you use one point to solve for. And in this case, the a is 7. The next one is really when someone just gives you a graph and then you are to find the quadratic function. So what is it useful for? Maybe you are actually looking at some phenomena. You see that they are like kind of like can be modeled in this situation, right? And you want to, okay, just actually find the equation so you can find all the other points. So what you can do is because you see the whole graph, most important thing is the vertex HK. So the vertex is what? -1, 3. And then one more point, right? One point. The point has to be on a grid line. So you can choose this one. You can, oh, this one is a good one, but I would rather choose this one that has a 0 with 0, comma 1, right? On the y-intercept, there's a 0, comma 1. Don't choose things that is like halfway between. You don't know what they are. So once you have the vertex, you can write it as the template. So you would say y equal to a x plus 1 square plus 3. Remember, minus h minus -1 is plus, and this is k. So then I'll use the second point, y, 1 equal to a, 0 plus 1 square plus 3. So 1 is equal to a times 1 plus 3. So what is a? A is 1 minus 3 equal to a equal to -2. So you can tell that it is a downward parabola